Now here the two NAD molecules here, you can simply here say that 2 NAD positive, that's from the left hand side of the reaction, is reduced to form 2 NADH molecules, that is on the right side, and you can say they are simply reduced to form 2 NADH. Why it gets reduced? Because it gets electron. This is reduced, you can say reduced, and it forms NADH. And why it gets reduced? Because it gets electrons here and it gets reduced and form NADH. NADH simply here. So the 2 ATP here yields during the glycolysis, that's the 2 ATP used in the metabolic process, and 2 NADH molecules enters the ETC, that is electron transfer, electron transport chain, right? These are used, that is here they will form into ETC. So the 2 ATP yield during the glycolysis, that's the 2 ATP used in the metabolic process, and 2 NADH molecules enters the ETC, that is the electron transport chain, and finally gets into the oxidative phosphorylation and use ATP also as the main aim. Here you can say the main aim here is to yield ATP, that is these one ATP molecules, right? From the glucose molecules. Initially we got ATP from the glycolysis, then this NADH molecule, it gives us ATP again in oxidative phosphorylation as one NADH molecule. You can say NADH molecule yields, you can say it yields 2.5 ATP molecules through simply through electron transport ETC, that is electron transport chain. But this all occurs in the presence of oxygen, when oxygen is there, right? But what will happen when oxygen acts as a final electron acceptor in ETC? So when oxygen is absent, all becomes non-existent. You can say non-existent. So when oxygen is absent, when final electron acceptor is not oxygen, it is the other species like organic or inorganic molecules. What happens here? The ETC chain, the NADH will not yield 2.5 ATPs, and it will not give us ATP, and there will be no ETC, and there will be no oxidative phosphorylation. So what will happen to NADH molecule? Will it be lost? No, it will transform again to NAD plus molecule. Finally, that is NADH finally converts back to NAD plus positive, and that's the you can say the conversion, or you can say that is the NADH will be, you can say, oxidized to NAD plus positive, and the conversion of this NADH to NAD positive is the fermentation process. So I hope you have followed this process of this reaction mechanism, and you have followed this chain reaction. So let's proceed again from the next slide.